Hello everyone, welcome back. So today in this video I'll discuss about projectile motion. In projectile motion we will basically calculate three things here. One is range, we will calculate the height, maximum height. We will also calculate time of flight. So these three things we will calculate for the projectile motion. Now we will neglect the air resistance. Let's say an object is thrown, right, making some angle theta with the horizontal, and the motion is like this. So from here to here the object is traveling under the action of gravity only, and this is called range. The height, the maximum, it is, let's say, h, and the time it takes to reach again the ground, this is time of flight. So these three things we will calculate. Let's say it is thrown with a angle theta, right? The object is thrown with an initial velocity u. So u will have two components, right? It will have a component along x-axis, it will have a component along y-axis. So u x component will be u cos theta, its y component will be u sin theta. We will write it, let's say, u subscript x, that is the x component, and u subscript y, that is the y component. Now equation of motion we can write. So equation of motion, you know that is equal to ut plus half at square. So if we want to write equations, two equations will write the equation of motion along y direction, equation of motion along x direction. So equation of motion along y direction, it is y equal to ut, uy of course we will write uyt plus half ay t square. Now two assumptions we will take for this projectile motion. One is when the object is traveling in the air, where of course neglecting the air resistance. Second assumption we will take that as it is moving under the action of gravity only, there is no external force acting on the object when it is in the air or during its motion. There is no external force acting here. So we will write that there is no component of acceleration along x-axis. So we will write ax equal to 0, only gravity is pulling and the motion is upward. So we will write ay is minus j. These things will take as our basic requirement. So here you can see ax 0, ay minus j. So if we will replace these values uy and ay, so my equation of motion along y-axis will become u sin theta t plus this one I'll write minus, because I'll write ay as minus j. So this is half j minus j t square. This is my y equation motion. Now I can write my x equation of motion also, x equal to u xt plus half ax t square. Now this term will become 0 because ax we have taken no acceleration along x-axis, because no force is there in x direction basically. So my x equation motion is u cos theta t. So these two equations we got for our equations of motion. Now we'll find out the time of flight. So let us find out first time of flight. So for that, let us choose one point. Let's say this is A point, this is B point. So if I'll write at point B, at B what will happen? Just look at the coordinate here, point B. So at point B, the coordinate of y will become 0. The displacement will become 0. Y displacement. Yes or no? Because it's coming and touching the ground again here. So at this position, your y coordinate will become 0. So if I'll put in the equation 1 that 0 equal to, so from equation 1 I can write like this. From equation 1 I can write this is 0 equal to so u sin theta t minus half gt square. So u sin theta t minus half gt square. Now what I can do, I can take common t, I can take t common. So 0 equal to t common, that is u sin theta minus half gt. Now see, when two things are multiplied and the result is 0, then either of them is 0, right? Either t0 or this quantity will be 0. You can think like this: if x into y equal to 0, so either x0 or y equal to 0. Either of them are 0, right? So here also we can write either t equal to 0, or you can write that u sin theta minus half gt equal to 0. Now see, t cannot be 0. Why? Because it has traveled and reached B. So it might have taken some time. It cannot take 0 time because to reach from A to B, right? It definitely have taken some time. So we'll discard this argument. We'll take u sin theta minus half gt equal to 0. Now if we'll rearrange, take left side, right side, this one to the right side, and let us rearrange it. We can find easily the time of flight. So this is time of flight derivation. You can do another way also. You can find. So fine. So you can write that half gt equal to u sin theta. You can write that t equal to cross multiply 2u sin theta by 2u sin theta by g. So this is your time of flight. This is your time of flight. Now we'll go for height, we'll go for range. Range we can find out easily, so let us go for range first. So let us go for range. Now range, if we want to find, you see that from equation 2 your because x equal to u cos theta t, right? So at position B only if I'll put my time of flight t, right, then I'll get this range r, because this is the x equation of motion along x direction. So I'll get r. So from equation 2 what I can write, my x equal to u cos theta t. Now t is the time of flight which we got. This time we can use, this much of time it has taken. So 2u sin theta by j, right? So we can write this is u square. 2 sin theta cos theta I can write as a formula. 2 sin theta cos theta is sin 2 theta. Remember this, 2 Sin theta cos theta equal to sin 2 theta, right? So we have used that. So this is your R or X range. Now we got range, we got time of flight. Our last part is to find out height, maximum height, how high it will go, right? So for that, let us find out its velocity. So velocity at this position, it will have two components. One is Vx, x direction, and Vy, y direction. Now see, whenever we are throwing some object, may it be projectile, may be straight. So when we are throwing upward, it will have some initial velocity, it will go up further, and as it is going against the gravity, it will go up, then it will become, its speed becomes 0 and it will fall down, right? So at maximum height, the y component must be 0. So we'll take that condition. So height, so what we'll do, let's say this is position C. At C, what will happen? Your Vy, V is equal to ut plus u plus at, uy plus ayt. Now uy is initial u sin theta and ay is minus g and t, Vy is 0. So if we just rearrange, we can find out that t equal to u sin theta by z. Now you see, this is the time it will take to reach the maximum height. So which is exactly, you can see at half of the time of flight. This is time of flight. So you can write this is t dash, t as t. This is time of flight, and t dash is the t dash you can use. So this much of time it is taking to reach the maximum height, right here, and this time is exactly half of the time of flight. So if we'll use this time of flight in your y equation, because height we are finding out, so in y equation if we'll use this time, so we'll definitely get the your maximum height, right? So what we can do, we can write y equal to, from equation 2, y equal to u sin theta t. U sin theta t is this one, that is u sin theta by z minus half gt square, half g t square is u square, u sin theta by z whole square t square. Now you see, g square, if I write square and g square, then g cancelled out. So here also it is u square sin square theta by z, here also u square sin square theta by z. So it will, you can take common, so y equal to basically 1 minus half, that is half u square sin square theta by z. Half, you can see u square sin square theta by g, you can take common. So here 1, it is minus half, so 1 minus half is, this one is common, right? 1 minus half. So you can write your h equal to half u square sin square theta by z. This is sin, not sin 2 theta, sin square theta. So this is the complete derivation for your range, height, maximum height, time of flight. What is the time, how much time it will take to reach the maximum height? Exactly, it is half of the time of flight, right? So all these things we have derived almost very clearly. Still, if you find any difficulties or any shapes not clear, you can comment. If possible, I'll make a separate video and clarify your doubt. So that's it for today. See you in another video, another topic. Till then, bye bye.